Hi viewers, I am Dr. N. Uttarasamy, Professor, Department of Mathematics, K.S. Rangasamy College of Technology, Tiruchengood, Namakkal, Tamil Nadu, India. In this video, we are going to discuss linear differential equations of second and higher order. Introduction. A differential equation of the form f of x, y, dy by dx, d square y by dx square, and so on up to d power n y divided by dx power n, that is equal to 0, which is the dependent variable of x and its derivatives dy by dx, d square y by dx square, and so on, occur in first degree and are not multiplied together is called a linear differential equation. Linear differential equation with a constant coefficient. A general linear differential equation of nth order with the constant coefficients is given by k0 d power ny divided by dx power n plus k1 d power n minus 1 y divided by dx power n minus 1 plus and so on plus kny, that is equal to capital F of x, where k's are constant. K0, K1, K2 and so on up to Kn are constants, and this right hand side f of x is a function of x alone or constants. So this equation can be written as K0 d power n plus K1 d to the power n minus 1 plus and so on plus Kn minus 1 into d plus Kn into y, that is equal to capital F of x. This equation can be written as f of d into y, that is equal to f of x, where dn is equal to d power n divided by dx power n and so on, and d is equal to d by dx are called differential operator. Solving linear differential equations with the constant coefficient. The complete solutions of the differential equation f of d into y is equal to f of x. Capital F of x is given by, that is y is equal to solution y is equal to complementary function plus particular integral. Then the right hand side is equal to 0 means what the solution y is equal to only complementary function. How to find the complementary function? So first one, consider the equation k0, k1, k2 and so on up to kn are constants, and dn, nth derivative, and d power n minus 1 plus and so on plus kn minus 1 into d plus kn into y is equal to f of x. So first we are going to put d is equal to m. Auxiliary equation is given by f of m is equal to 0. This can be written as k0 d is equal to m means m to the power n plus k1 m to the power n minus 1 plus and so on plus kn minus 1 into m plus kn, that is equal to 0. Next step, we are going to solve this equation, find the roots. If n roots of auxiliary equation are real and distinct or different, say m1, m2, m3 and so on mn, so all the roots are different and real. So the complementary function c1 e power m1x plus c2 e to the power m2x plus and so on plus cn e to the power mnx, so where c1, c2, c3 and so on up to cn are constants. This m1, m2, m3, m4 and so on mn are roots of this auxiliary equation. Next is case if two or more roots are equal, that is m1 is equal to m2, that is equal to m3 and so on. So roots are real and equal. The complementary function, that is c1 plus c2x, suppose any two roots are equal, that is m1 is equal to m2 means we can write c1 plus c2x into e to the power this mx. Any three roots are equal, so that is c1 plus c2x plus c3x square into e to the power this corresponding root, that is common m into x plus and so on. Suppose the auxiliary equation has a pair of imaginary roots, that is alpha plus or minus I beta. The complementary function e power alpha x into c1 cos beta x plus c2 sin beta x plus remaining roots are real and different means we can continue as in the first case. Suppose any two pair of imaginary roots are equal. M1 is equal to M2 is equal to alpha plus I beta and M3 is equal to M4 is equal to alpha minus I beta. The complementary function e power ax into C1 plus C2x cos beta x plus C3 plus C4x sin beta x plus and so on. So this is these four cases we are going to apply in the differential equation to find the complementary function. Then simple example using these four cases. So first one, solve the differential equation. D square y by dx square minus 8 into dy by dx plus 15y is equal to 0. So already we know d square by dx square, that is equal to d square, and d by dx, that is equal to d, and 15y. So commonly this equation can be written as d square y minus 8 dy plus 15y, that is equal to 0. So in the solution we are taking outside this y. So d square minus 8d plus 15, that is equal to 0. And next we can write the auxiliary equation. D is equal to m. M square minus 8m plus 15, that is equal to 0. So we can find the roots using synthetic division or whatever it is, quadratic equation. And that is m is equal to minus b plus or minus square root of b square minus 4a whole divided by 2a. Using any one of the method, find the roots. So the roots m is equal to 3, 5. These roots are real and different. So m1 is equal to 3 and m2 is equal to 5. Therefore the complementary function c1 e power 3x plus c2 e to the power 5x. Since f of x is equal to 0 on the right hand side, so the solution of the given equation, that is y is equal to the complementary function, be the solution. Therefore y is equal to c1 e power 3x plus c2 e power 5x. So here the roots are real and different means already we know. That is y is equal to c1 e power m1x plus c2 e to the power m2x. Here m1 is equal to 3 and m2 is equal to 5. So next example, solve the differential equation d cube y divided by dx power 3 minus 6 into d square y by dx square plus 11 dy by dx minus 6y, that is equal to 0. So we can write this equation d cube by dx power 3 d cube and d square by dx square d square and d by dx, that is equal to d, and next this common y we are taking outside. That is what, d cube minus 6d square plus 11d minus 6 into y, that is equal to 0. This is actually equation d is equal to m cube minus 6m square plus 11m minus 6 equal to 0. So using synthetic division we can find the roots. The roots are 1, 2, 3. Roots are real and different. So d cube and this corresponding auxiliary equation m cube, m has 3 values. The values are 1, 2, 3. Using any one of the method, we can easily find the roots. The roots are m1 is equal to 1, m2 is equal to 2 and m3 is equal to 3. So what is the complementary function? That is cf is equal to c1 e power x e power 1x plus c2 e to the power 2x plus c3 e power 3x. And right hand side is equal to 0. Therefore, this complementary function be the solution of the given problem. That is y is equal to c1 e power x plus c2 e power 2x plus c3 e power 3x. Next one more problem. D cube y by dx power 3 plus 2 into d square y by dx square plus dy by dx, that is equal to 0. So in this problem we can write d cube y plus 2 d square y plus dy, that is equal to 0. So next we are taking outside this y, and we can write the auxiliary equation m cube plus 2m square plus m is equal to 0. So what are the values of m? M has 3 values. So here m is equal to 0, minus 1, minus 1. So in this case, minus 1, minus 1, minus 1 is repeated 2 times. So therefore roots are real and equal. So first we can write m1 is equal to 0, m2 is equal to, m3 is equal to minus 1. So therefore the complementary function c1 e power 0x. So e power 0, that is equal to 1. So we are writing c1 plus c2 plus c3x into e to the power minus x. Suppose this minus 1, minus 1, minus 1. Minus 1 is repeated, that is 3 times, means we can write what is c2 plus c3x plus c4x square into e to the power minus x. Okay, so in this problem, right hand side that is equal to 0. Therefore, this is the complementary function be the solution of the given problem. Next problem, d power 4y divided by dx power 4 minus 2 into d square y by dx square plus y is equal to 0. So this can be written as d square minus 2d power 4 minus 2 d square plus 1 into y, that is equal to 0. This is the auxiliary equation. M power 4 minus 2m square plus 1 is equal to 0. So therefore, m has 4 values, m to the power 4. So that is equal to what? Minus 1 comma minus 1, 1 comma 1. So these 4 values, that is m1, m2, m3, m4. So that is m1, m2 is repeated and m3, m4 is also, that is equal. So this is minus 1 comma minus 1. So first is c1 plus c2x e power minus x plus c3 plus c4x e to the power plus 1x. So this is the solution of the given problem. That is complementary function, that is equal to solution y is equal to c1 plus c2x e power minus x plus c4 plus c3 plus c4x e power minus x. And similarly we can work out the another problem. This is way to find the complementary function. Next we are going to find out the particular integral in the type 1 only. If in the right hand side is equal to e power alpha x, right hand side e power alpha x or ax. So first one, we can write particular integral, that is 1 divided by f of d into e power ax, that is equal to 1 divided by f of a e power ax. So here in the denominator, f of a is not equal to 0 means this is the particular integral. Next one, suppose f of a is equal to 0. So we can multiply x in the numerator and the denominator, this f of d differentiate with respect to d one time. So that is f dash of d e power ax. So that is equal to x into 1 divided by f dash of a into e power ax. So in this case, f dash of a is not equal to 0 means this is the particular integral. Suppose f dash of a is equal to 0 means once again we have to multiply x in the numerator, already x, so multiply with the x means x square into f dash of d, multiply one more time, differentiate with respect to d, that is x square 1 divided by f dash of a into e to the power ax. Similarly and so on. So this is the first type to find the particular integral. Solve the differential equation d square y by dx square minus 2 into dy by dx plus 10y, that is equal to e power 2x. E power 2x. Solution, d square minus 2d plus 10y, 10 into y, that is equal to e power 2x. So auxiliary equation is m square minus 2m plus 10 is equal to 0. So therefore m is equal to 1 plus or minus 3i. Roots are imaginary. The complementary function, m is equal to alpha plus or minus I beta means e to the power alpha x into c1 cos beta x plus c2 sin beta x. So here alpha is equal to 1 and beta is equal to 3. Therefore e power x into c1 cos 3x plus c2 sin 3x. Then find the particular integral, 1 divided by f of d into f of x is equal to 1 divided by f of d into e power 2x, that is equal to 1 divided by f of 2. We are substituting d is equal to 2 e power 2x by putting d is equal to 2. So after substituting we are getting 1 divided by 10 into e power 2x. The complete solution, complementary function plus particular integral. Therefore y is equal to e power x into c1 cos 3x plus c2 sin 3x plus 1 by 10 e to the power 2x. So similarly we can work out another problem. It's a problem, d square plus d minus 2 into y is equal to e power x. For write the auxiliary equation, roots are 1 comma minus 2 and particular integral, you can see denominator 0. Denominator 0 means we are multiply x and divided by this d square plus d minus 2, we can differentiate with respect to d. So finally we are getting this one. This particular integral x e power x divided by 3. Thank you.